So to get the software, you go to this web page, intel.com. You go to support, download center for FPGA. You go there, then you go to design software, and we need Quartus Prime Lite edition because it is free. So you click there, and then you have to download the Quartus software, 1.6 gigabytes, model sim 1.2 gigabytes. You click there. That is for simulation, and to support the device we have to download this file. And I'm pretty sure when you install Quartus software and you run the software, it will ask you to specify the device support file, and you just point to this file, and it will be just enough. Hello everyone. And program Altera. So first, what we do is connect model Quartus. We do this by copying, pasting the executor address by going to start menu, open model sim, and then right click location and right click file, and you copy this address here. See? You put it there. So this is perfect. And you click and you give it a name. So let's go to text. Run. Yes, empty project. Yes, empty. Then you either select the FPGA from this list, and then if you do this, then you have to deal with the constraints file. So you have to connect each variable to the pin, each signal to this specific pin, and etc. But you can select the proper development board into boards, and this file should be ticked. And in such case, the constraints file is generated automatically. So here again, you select the simulation tool is Model Sim Altera, and then you click next, and then you click finish. Now let's wait for a moment. So here I have this file generated. That is basically the all pinouts I have in this board. So in my case, I will delete everything that I do not need. So I will keep LED and switches. So I kept this LED because it's 9 bits and switches are also 9. So what I will do is assign ADR to the value of switches. Good. Save, and now first what I will do is I will simulate until I put it on FPGA. So you press new, you select Verilog HDL and OK. Here I paste the code that I already wrote, and we call it TB for test bench. So note, I put lower score error into the variables that I use in the test bench that I created there, just for you to notice in the simulation. So inputs should be register type, outputs should be wire type. So this is the instantiation, and here I just have the stimulus. So it should be 5, and after this main time it should be number 15. So now I right click into this test bench file here, and I set it as a top level entity, and this should be selected to RTL simulation because I am simulating, and right click here. Now you wait for a moment, and after a couple of moments, in my case it's 18 seconds, model sim is launched here. So let's put it on full screen mode. So in your case you don't have this black waveform window, but don't worry. Here I have test bench and baseline. So if I mistakenly did not select this as a top module, this and this file was top module by default, and I will, in this work library, I will have only the first file. But you should not do this. You should follow me in this case. So you select test bench if everything is okay, and click simulate. Right click simulate. Then you select both of these files and click add to wave, and then you just click simulate. Here you check the time, you see it's correct. So if you want to reset, let's see, simulate here, restart. So you can click restart actually. Good, and then you just do this. But yeah, there is short button for this also. Here, restart. So simulation works. Now I will not proceed with this step anymore. You can deal with simulation files later, and I will put it to compilation mode. And now this is a test bench, and I press compile design. Is the USB cable, and then click hardware again. Make sure FPGA is turned on. You can turn it on with the red button next to the power source. So you select USB blaster here and close, and so cool here. You can click auto detect if something is wrong, and you select this device and press start. So it will program the FPGA. So let's see when this is finished. Now it's finished, and I am checking it, but I cannot show it on video, but it's working. So, and if I pull up the switch, it will turn on the LED, corresponding LED, and etc. So this works, implementation works. So far so good. That is the basic things you should be able to do, and after this you will just improve the code and make it to fit the requirements of the lab.